All right, everyone. Well, thanks for inviting me. My name is Mike McWhorter. I'm an engineer with, he's giving me, oh, talking to him. I'm an engineer with Western Digital. And Western Digital has been doing a lot of work recently with Hadoop and object storage. When we talk to our big data customers, one of the things we find that they all have in common is they all have lots and lots of data, petabytes of data, and they're struggling to find enough disk space to store it all. When it comes to Hadoop, the open source community's come up with a really innovative solution to this, and it involves integrating Hadoop with an S3 compatible object store. This allows you to add petabytes of storage to Hadoop instantly without having to scale your cluster or make any changes to your production system. There's a new feature in Hadoop. It's called S3A. This is the S3 adapter for Hadoop. It allows you to connect any S3 compatible object store to your Hadoop cluster to act as a second tier of storage. From the user's perspective, it looks just like another directory in HDFS. You can copy files there, you can run MapReduce jobs on it, you can store Hive tables on it, but under the covers, it's an object store.
Is this the Ozone that they're talking about?
The what?
Ozone.
Ozone?
Yeah, I think Hadoop came out with something like a key value store that is actually meant for smaller objects and so on. Is that something to do with
Oh no, I'm not familiar with that.
Okay.
No, this is sort of to augment HDFS.
Mm-hmm. Okay.
So is it a tier or is it it's actually just basic storage for Hadoop? Is that what
Yeah, it's basic storage for Hadoop. It's kind of like an HDFS emulator. So you connect your object store to it, and the bucket in the object store looks exactly like a directory in HDFS. And this is, instead of being HDFS storage, this is object storage, which means it's optimized for capacity and uses things like erasure coding to store your data, as opposed to HDFS, which mainly uses triple replication and is optimized for MapReduce performance rather than capacity. S3A was created to address the storage problems that a lot of Hadoop users were having with HDFS. So in the big data world, data sets get really, really large, frequently approaching the petabyte range. When you have this much data, finding enough space to store everything is a big challenge. And HDFS exacerbates the problem because it relies on triple replication to store your data. By default, it makes 3 copies of everything. The default replication factor is 3. This does a good job of protecting your data, but it uses a lot of disk space. So in this example here, we've got 3 drives. These are 14 terabyte drives. Shameless product placement. For a total of 42 terabytes of physical storage. But once you apply triple replication to this, that's only 14 terabytes usable. So you've got 42 raw, 14 usable. It's not a great ratio. If you've got a small data set, it's okay, but this is big data we're talking about. And when you try to deploy this at the petabyte range, you end up running out of space very quickly. It gets very expensive. When these file systems inevitably run out of space, users are forced to make difficult decisions with their data, and they'll often end up deleting valuable business intelligence data that they really wanted to keep just to free up disk space and open up more space in HDFS. Before S3A was created, the traditional way to add storage to Hadoop was to scale out. So if all your drive bays are full and you need to add more storage, that means you have to add another block of servers. And that includes all the extra CPUs and memory and infrastructure costs that go along with it. And keep in mind, really, all we wanted to do was add disk space. Your Hadoop cluster may be fast enough. You may have all the compute power that you want, but in order to add disk space, you're forced to purchase more CPUs and more licenses. That's usually the big ticket item, just to get a couple extra petabytes of disk space. HDFS is a giant disk hog with triple replication, but it's really hard to get rid of it. HDFS and MapReduce are very tightly coupled, and Hadoop goes to great lengths to make sure that your data stays as close to the processor as possible. And the HDFS triple replication setup is also tied into the way it does failover and redundancy. So It's really difficult to get rid of it. This is one of the core principles behind what makes Hadoop able to scale to thousands of nodes without hitting any kind of performance or network bottlenecks. And at first glance, it would appear that adding an object store to this kind of violates that model. But keep in mind that this only applies to your active data set. So adding an object store to Hadoop will allow you to expand your storage capacity without affecting performance. We just have to be careful about how we do it. So here's what I mean. This is your data set. And I know this is a hard drive icon. This represents a logical data set. So think it's spread across hundreds of disks. It's really big. But only a portion of it is going to be active at any given time. This orange slice here is the active portion of your data set. And in Hadoop land, the active portion of your data set is called your working set. So this is the subset of your data that you're using to
Do active map reduce stuff on it? Stuff?
Yeah. So to work on your current analytic job, whatever you're currently running. Now, ideally, we want our working set to be on the fastest storage we can. Generally, that's memory. When people build Hadoop clusters, they try to build them such that the entire working set fits in DRAM. That's not always feasible. Some working sets are really large. You can't fit them in DRAM. If you can't fit it in memory, you at least want it to be on the fastest storage medium, which is HDFS. But for everything else, for the other 90% of your data, that's a great candidate for object storage. You can migrate that off to the object store, where the cost per gigabyte is a lot lower and the scaling properties are a lot better, at least in terms of density. Now, again, the goal of this is not to replace HDFS, but to augment it with a second tier of low-cost storage. So you keep your hot data over here in HDFS and migrate your cold data or your historical data over into the object store as it ages. In real-world scenarios, when we're engaging with customers, the way this normally looks is they use it to store their historical data. So when you're collecting data and performing analytics on it, the newest data that's your hot data. That's what you're going to analyze first. But as more and more data comes in, what was previously your active data gets accessed less and less frequently until eventually it can be archived off into an object store.
Is this archive a manual operation to some extent, or is it's not like an ActiveScale function or something like that that's going to archive active Hadoop data to object store?
No, it's going to look like two directories, but there are ways to do it so that it's automated. For example, if you want to have if you're setting up Hive, right? You could partition your Hive table so that the active portion is in HDFS and the historical subset of your data is stored in the object store. So it looks like two directories, but you can automate that move. Now this is historical data. It's not being accessed very frequently, but it's still extremely important, and we still need to keep it because we're going to have to refer back to it from time to time. Historical data is how we predict long-term trends and seasonal changes in user activity. Before this was invented, the way people were running is they'd keep maybe a couple months of data online, and then HDFS would fill up, and they'd have to delete it. And well, what do we delete? Well, I guess we'll just delete the oldest data first, and over time, more and more data is coming in faster and faster. So instead of maybe 3 months of data, you can only keep 2 months of data online. And it's a shame because you're missing out on all of that business intelligence. You can't predict long-term trends anymore because you have to throw away your data. And data analysts do not like to throw away data. Now, I said before, you want your working set to be on the fastest storage possible. If your data set is small enough so that it can fit into memory, you can actually run analytics directly on the object store. So for in-memory workloads, if you're running Spark, or if you've got, say, an Impala database, Impala makes heavy use of DRAM caching. The way these things generally work is when the service starts up, it takes all the data from disk and loads it into DRAM, and then from that point on, it just works on the memory copy and barely touches the disk. So for operations like that, you can run your analytics job directly on the object store without any degradation in performance. There's a slight delay at load time when it's loading the data from the object store into memory. HDFS is a little bit faster than the object store, so there's going to be a slight delay there. But once it's all in memory, you're running at full speed. And we've had great success there. Customers have told us it's running very close to the speed of HDFS for the in-memory working sets. Now here's what it looks like in practice. I know you were asking what this looked like. I've got 2 screenshots here. The top one is a directory listing in HDFS. So this is just a standard directory listing. The command is Hadoop fs-ls/. I know I'm using the deprecated syntax. Please ignore that. This gives us a directory listing of just the root of your HDFS file system. Down here, this is a directory listing in S3A. So it's the same command, Hadoop fs-ls, only instead of the Hadoop path, you have this S3A prefix. So it's S3A:// and then your bucket name. You can substitute this S3A prefix anywhere you have an HDFS path. So you can put Hive tables there, you can copy files to it, you could run MapReduce jobs directly on it or pipe your output there. It's a really neat solution because the user doesn't have to learn anything new. You just substitute this for your HDFS path and that's about it. I should also add Western Digital is a Hadoop code contributor. We've contributed several enhancements to S3A to help make it run faster, such as local caching, multi-part uploads, partial object reads, and there are a lot of neat things that we've added, a lot of performance tweaks that we've added into the core.xml file that allow you to tune this for performance, and we have all of the Hadoop and S3A experts in-house that can help you with that. So I know this isn't supposed to be a sales pitch, but if you need any help tuning your Hadoop cluster for object storage, or if you're looking for an object store, we have a really great one. There are a lot out there. We think ours is the best. Since we manufacture the drives ourselves, we can get really aggressive on the pricing.